Hello everyone and welcome to OpenInfra Live. For today's episode, the Large-Scale OpenStack show is back. Large-Scale OpenStack is a show for OpenStack operators by OpenStack operators. Organized by the Large-Scale SIG, we feature open discussions with operators and guests around how to run large-scale OpenStack deployments. Today's episode will be a deep dive into the Yahoo deployment. Yahoo was previously known as Verizon Media, Oath, and Yahoo, and they have run a massive OpenStack private cloud for quite some time. They were the first to reach the million core CPU core scale. So I'm pretty sure they have great stories to share. And so without further ado, let me introduce our cast for today. Our guests from Yahoo will be Brendan Conlan and Adam Harwell. And to discuss with them, our hosts today will be Mohamed Nazer from VexHost, Arnaud Morin from OVH Cloud, and Belmiro Moreira from CERN, who will be moderating the discussion. So Belmiro, take it away.
Thank you, Thierry. Hello, everyone. I'm really excited with today's episode and have Adam and Brendan here to discuss the large-scale Yahoo compute infrastructure. But first, let us know more about you and how did you started with OpenStack, actually? Adam, you want to start?
Sure, thanks. I actually started with OpenStack way back in 2014 when I was at Rackspace. So I've been through a couple of organizations since then, but I started off as a founder of the Octavia load balancing project. So I was doing load balancing at the time at Rackspace, and we spun that up, and I got sort of introduced to the upstream community and have had a ton of fun with it since then.
Nice. How about you, Brendan?
Yeah, so I'm a little different. About 10 years ago was my first introduction to OpenStack, and that was actually as a user in the Yahoo search team. At that point, the OpenStack infrastructure in the company was being spun up. It was the initial implementation. So I was a user for a while, and then 3 years ago, there was an opportunity to set up an operations team in Taiwan. I'm actually based in Taiwan, so I took the opportunity to be a technical manager, so a hands-on manager, doing operational work and setting up a team in Taiwan to help have more global coverage within the global OpenStack team within Yahoos.
Nice.
Yeah, it's been a fun journey.
So I think now the big question, the question that everyone wants to hear about is, how about your infrastructure? So it was announced that Yahoo now has more than 1 million cores on OpenStack. So how your infrastructure looks like?
Yeah, so we have a large infrastructure footprint, obviously. We have multiple geolocations around the globe to support the Yahoo services. And then within those, we have multiple different clusters as well. So we have clusters supporting the personal virtualization, where we give all the developers, personal VM boxes just to use instead of having desktops. Previously in the company, everybody would have a desktop. When I joined, you were given a PC that you put under your desk, and it was your pet. You kept it, you cared for it, you looked after it, and it was special. And everybody treated compute that way. And now, when you join the company, you actually have the opportunity to spin up virtual machines on different geolocations for free and just use them as your development system. So we have that. We have bare metal clusters. We have different virtual machine clusters. And then we actually also have a new environment that we're spinning up as well it's really combining the personal and virtual machines in the same clusters using newer releases of OpenStack and newer features. So roughly 40, 50-ish clusters around the world.
Mm-hmm. So by cluster, you mean different regions?
Yeah, different regions, different like OpenStack installs. So completely separate systems, separate networks.
Mm-hmm. Okay.
All of them are completely separated. No keystone in common or no component in common, right? Okay.
Yeah, we have some things. I believe, Adam, you can correct me if I'm wrong, but some of them keystone or common.
Yeah. So for the most part, though, they're all actual separate clouds. So like our clouds.yaml file is extensive, and we actually give our developers an RPM or a get download location for that.
Right, but your decision to have these completely isolated regions, it's because business decision or because the scalability of OpenStack? So what was the motivation to have this architecture?
A lot of it's the business decisions and the architecture of the company. With the networking, sometimes it simplifies things for us in a way. It makes things more complicated, but it also simplifies other things.
No, yeah, I understand that, because I was imagining like 1 million cores in one OpenStack instance. That would be pretty crazy. And
yeah, you could imagine if there was any required updates that required downtime would be rather scary.
How do you deal with connectivity across those different sites? Like, do you have some sort of shared network that's available across all these sites where a user can kind of provision a VM here, a VM there, and they'll be able to just have shared connectivity out of the box, or that's kind of a user problem?
Yeah, I think that's a pretty standard, large internet company way to do things. So we have our own backplanes, obviously, with our own interconnects. So the actual co-locations are interconnected.
But from a like a user point of view, it's pretty easy to just spin up a VM here, spin up a VM there, and have them talk to each other, not over the internet.
Yeah, it's relatively straightforward. We're moving forward in the new clusters to have the zero trust model, where the networks are a lot more open, and we can allow the teams to apply their own security groups, and that's tied in with the Yahoo company networking controls, the ACL controls.
Yeah. I think also what's interesting is when you bring up something like that is when you have all these kind of different keystones, I guess, and you have such a big clouds YAML file, are you using any federated authentication or anything like that so that you're not maintaining like a whole bunch of users, or you're just backed by LDAP? What's kind of can you talk about that? Maybe you can, that's fine.
Yeah, I think
do you want to take that, Brendan, or do you want me to take that one?
Do you want to take that one? You probably
I can kind of talk about
more details.
So yeah, Keystone is backed by we use an authentication system called Athens, which is an X509 mutual auth system. So we actually do our user auth in one centralized place in Athens, and then all of the keystones globally just communicate back into that system. So that's where if you think of all of those keystones, it seems kind of crazy, right? But they don't all have their own authDB or anything. That's all sort of more centralized.
So Keystone essentially is just generating tokens for OpenStack, but the authentication is something else is taking care of it, and Keystone is just giving a token for that specific cloud.
Yeah, Keystone basically handles the token, the OpenStack side token, but then all of that stuff and all of the actual auth model stuff does just get passed through to another system, and I believe that is open source as well.
I think Athens is open source. I don't know if the OpenStack bits are, but cool.
Well, that keystone, how the way you use it is interesting, but I have a similar question about Glance, because if you have all these different clouds, so how you deal with images? So you replicate them everywhere. You have a centralized store that every Glance connects to.
Yeah, we use automation to replicate that across all the different clusters. Yeah, the way we treat a cluster as well is it's a standalone because it's in a different co-location, and we have the teams that use our system have their own business continuity planning. So they'll plan to have multiple locations where if one data center goes completely down, they can still manage to run their properties on the internet. So we treat everything very segregated and siloed, and that's one of the reasons why we do that. So yeah, we just have automation jobs that push. So we have one place that we can go and trigger image deployments, and it will deploy across all the clusters for us.
Right. But that is something that you developed, right? Because in OpenStack world, there is nothing that can trigger that replication everywhere.
Yeah, we use another plug here from some more open source Yahoo technology. So Screwdriver, I don't know if any of you guys are familiar with Screwdriver. So Screwdriver is a like CI/CD automation system that was developed internally in Yahoo due to scalability issues we had using Jenkins. So Screwdriver is a very scalable way to do deployments over hundreds of thousands of systems. So it gives us the ability to do some very nice configuration within it. So we can actually have our own Screwdriver images that are custom, that we define and create with templates and steps that can be specific to OpenStack. So if we specify our own templates that have steps, and it's very, very configurable and reusable across all the clusters. So we can quite quickly spin up automation that does a lot of these things for us.
And I guess while we're on the topic of many clouds and how do you deal with that? What about dashboards? Like, do you kind of have your own internal dashboard that replaces Horizon, or do you just have many Horizon endpoints and just go to the right one when you want to go and use a web interface?
Yes, we have two or three different Horizon versions that we run. Yeah, with just multiple options to pick the right cloud.
Yeah, I'm trying to remember how custom that is. I know we wrote something around that to make those regions show up properly, but I don't think it was a major change.
Mm-hmm. So there's still kind of like one main Horizon kind of at the end of the day, which makes life a little bit easier when it comes to that.
Yeah, although I believe most of our users end up using the APIs or the command line.
Well, but having only one Horizon is not challenging because you have multiple keystones. So where they connect to, that'll be interesting. Okay. No,
Yeah,
just thinking. I'm just thinking loud.
Yeah, so when you go to our Horizon, it basically gives you sort of a drop-down choice about which region to connect to, and it picks the keystone at that point.
Okay.
So I'm thinking what you're mentioning, Adam, is you're not changing the drop down once you log in, like the region drop down inside. You have another one before you log in.
You can actually from inside it. And again, this is possible, I think, because the way that the auth works is that it's all centralized auth, right? So you're still using the same X509 identity. It's just the keystone needs to reissue a new token when you swap.
Right.
Okay, cool.
Okay. So you have all these different regions, these different clusters. How do you manage them? So you have some still in Diablo, others already in Wallaby. How this works? Like having so many clouds?
No. Yeah, we're not that far ahead yet. I think we have some still in a kata.
Well, it depends. So yeah, there's a lot of stuff, and I remember my first day at Yahoo, coming in and having my manager whiteboard okay, so we've got this cloud, this cloud, this cloud, this cloud, this cloud. These are on these versions. This is on and it's definitely fun to manage. But for the most part, I think we have two major setups right now. One is OKADA, and that's currently in the process of being upgraded to Wallaby, and in some cases a little beyond that. And then we have another cluster that's mostly running master, with a couple of exceptions.
Master.
Yes.
Nice. So you're
So-
upgrading it as a running upgrade, or
Yeah, and so this is where that's a very interesting point. So when we say master, it is in a sense point in time. So when we need specific upgrades or specific patches to pull down, or when we're looking to do an upgrade on a service, we will trigger a new build, or one will be triggered for us. Most of our stuff is just commit comes in, build, test, deploy. Not really hands-on so much, but we can also say, hey, we want to just have a new version of this go out and trigger a build of that.
so you
some
have
of them.
Yeah.
Some of the stuff that I say is on master is probably closer to even as far back as Xena in some cases, but some of it's a lot more recent as well. It's kind of a mixed deployment.
So even if you have, I don't know, a database schema change which is coming on master, how do you apply it? It's fully automated because you said you have some sort of
Yeah.
CI/CD. Yeah, it's fully
Yeah,
automated.
all of that. So when we get a build and we make a new version of whatever service that is, part of our automation is applying all the database stuff. We do have backups, but we haven't ever had to use them, cross fingers, or knock on wood. Yeah, it's been working fairly well so far. One caveat on that is that we have to be very careful with our downstream patches. We do have a few downstream patches, not so many on that specific cloud, but we have to be careful never to do our own schema changes, right? Because that'll conflict.
Yeah, to
So
not break
everything
the,
there. Yeah, the idea is stay as upstream as possible. If we need to do something, we get it upstream.
And how big is this master region? Because that sounds amazing.
So that is our newest cloud deployment. I don't know exactly how many cores that is. You know, Brendan?
Thousands of hypervisors.
Nice. So it's quite big.
Multiple thousands, yeah. It's in 6 geolocations.
And you're not using any custom mechanism behind Neutron, for example, or any other component. It's full upstream, full master.
Like I said, we have a few downstream patches, but they apply automatically as part of the build process. So, and we try to. There's an art that some of you may have experienced around making downstream patches that don't conflict. So we try our best to do things in that way. And if we can get anything upstreamed, we definitely try to do that first. Most of our patches are upstreamed and then pulled downstream until they merge.
And what about is that deployment, is it using any orchestration, or is it like containers? Is it just packages and Puppet and what's
So that deployment is still using our RPMs that we build, and then they're deployed via Chef. Although the newer stuff that we're working on is containerized and deployed via Ansible.
Cool.
So the life cycle of the infrastructure is handled by Chef, basically pushing RPM packages somewhere and just doing RPM install, right?
Yeah, basically packaged virtual environments. That's that particular one. We have, again, the number of clouds that we have is fairly large, and some of them are deployed in slightly different ways. For the most part, though, it's all Chef right now.
I wish OpenStack was just pushing a bunch of RPMs and packages and calling it a day.
So this master cluster is pretty interesting and quite challenging. But I think the big challenge is the old ones, the ones that you said that you still have in OKADA. So to move that forward to more recent versions, what's your workflow on this? What are your plans?
So there's a project that's been ongoing for a while. I think we just call it upgrade from OKADA because the end goal is a little bit nebulous. I think when we started, the goal was Wallaby because that was the latest release. So there's more now.
I think that gives you an indication of how much time this has been taking as well.
Yeah, right. Yes. But it's this undertaking, a lot of that actually was, the work was more around moving from this RPM based thing that's on Chef to a totally containerized deployment model that's based on Ansible. So not all of it was actually around the OpenStack stuff itself. It's a lot of other bits and pieces, moving parts. The plan is basically a large fast forward upgrade through however many versions that is, right? And again, not all the components are going to land on exactly the same version. This is one of my little pet things, is that OpenStack really doesn't need to be run on a single version. It's very simple in a lot of cases to run older and newer services together. I remember when I started working on Octavia, we would run Octavia Master, which at the time was, Queens, on a Liberty cloud, and that worked perfectly fine. Because it's all about knowing, what services each service interacts with as part of operation. So for the most part, you can upgrade stuff, not in lockstep.
Yeah. From OKADA is a huge, it's a huge step, right? Because also you're gonna jump different Python versions that are supported by OpenStack.
Yeah, we did another project to get off of Python 2 a while back, and so actually I can't remember whether all of the OKADA stuff actually made it to Py 3 or not. I think some of it may not have.
Yeah, I think there was only one component, didn't I think?
Yeah,
So
definitely a challenge.
Well, that raises kind of another interesting question, which I guess that probably big reason or part of the reason why you're moving to containerized is what about your underlying operating system, right? Depending on what, release you're running or what flavor of distro you're running, that's quite a bit of operating system upgrades too. So is that why you're containerizing, or kind of like what's your thoughts on that?
Yeah, that's one of the reasons. One of the reasons we have, we're trying to do regular OS upgrades, so we want to keep up to date with security patching specifically. So, we want to have a very regular cycle where we're doing that. So that's one of the reasons. Another reason is really, orchestration and rollouts and also rollbacks. Chef is, it's an okay orchestration tool. I think, people that have had a lot of experience with it know the benefits, but there's also drawbacks. So I think, moving towards the containerization is definitely a step we want to take in the future, and then we can actually look more into how we orchestrate that container deployment as well across all the clusters to try and automate things. With a very small team, we need to try and leverage as much automation as possible to try and free up time to focus on other issues.
And how do you manage then when you need to upgrade your hypervisor? How do you manage to move the load out of the hypervisor? Are you not moving it, shutting down maybe the instances, or are you moving the instances?
Yeah, at this point in time, we don't have any live migrate or anything like that. So yeah, it's very problematic for the users. Luckily, a lot of teams have some good automation involved, so they can handle it quite smoothly without any issues. They can take the downtime. Other teams, it's more problematic. So there's a lot of scheduling there. There's a lot of issues. So that's definitely something we're looking at changing going forward.
So you're not doing so much live migration. You're not doing live migration at all, right? Okay. So
I think
must be kind of nice.
Yeah, this is nice.
I don't know. We would actually quite like it.
Not for the users, but just as an operator, it's like, I don't have to worry
Yeah.
about that. That's
So
great. Just shut it down, restart it. Have a good day.
it still means you need to at least do the computes one by one or not in a bulk in order to avoid shutting down all the instances of your customer in a shot.
Yes, we have to, and that can be tricky. The scheduling,
Yeah.
understanding, what's where with so many teams. I mean, we have hundreds of teams with, thousands of projects all running across infrastructure. So that whole management piece can be very tricky and time consuming.
Yeah. And is it something you do manually, or you have any robot or any tool to help you in that?
We have some tooling to help it, but it's a semi-manual. It's only really, we don't have an end-to-end automated process flow, unfortunately, for that. I wish we did.
Okay.
If you know any, please help us. Let us know.
Right. I think we have a question from the audience. Thierry?
Yeah, we actually have two questions from the audience, and the first one is from Andrea Franceschini, asking how big are those regions? Like, can you give us some indication of the size and in terms of number of compute nodes?
It's probably in the region of, a single region could have 100,000 across the different systems, I think.
And the other question is from a very regular viewer, Seung-Soo Cho from Korea, asking what type of ML2 driver do you use, which is a much more precise question.
I don't actually know that off the top of my head. Adam, do you know?
So I am very self-professed not a networking person, but I can try to find the answer to that question really fast and possibly get back to that.
Okay, thank you all.
So can you go back again to the live migration question? So why not live migration? What is the motivation to not have it?
We are motivated to have it, but we have some issues on the way the company networking is in place, makes it tricky for us to be able to utilize live migration. I think that's probably the best way to explain it. So we would like to do it. We're still investigating to see if we can find a solution that would allow us to implement that, because it would definitely be a benefit for our users if we could have that in place.
Yeah, I think the major blocker for that, if I remember correctly, Brendan, was the hypervisor to hypervisor communication. Because of the way we do our security model, we just can't allow them to communicate the way that OpenStack expects.
Right. Yeah, it's quite open, actually.
Yeah, and we take security very seriously here. I mean, I'm not going to bring up history, but Yahoo has a history with security, and we do not allow that kind of openness in our infrastructure anymore. So that's been the major blocker.
But you still provide layer 2 networking between computes for the instances, or I mean, instances can communicate in a private network, right?
Yeah, I mean, they have their own like networking layer that they can communicate with each other. But I mean, the security model for the upstream live migrate typically has hypervisors communicating like directly to each other as basically root users, which is not
SSHing into each other.
Yeah, we don't allow that at all.
Yeah, I think the SSH stuff should probably be eventually pulled out at some point, because it's, especially if you have a shared, like you've shared block storage, it's just no point. It just needs to talk to libvirt. But speaking of that, what's the kind of the story of block storage at Yahoo? Like, is it Ceph? Is it Cinder with some insert vendor being used for block storage as a backing? Is it just local storage only?
So yeah, we're using Cinder with a vendor that we've chosen to support us on our new infrastructure. So we have have block storage available on the newer clouds that we've put in place. We're also leveraging some vanilla as well in certain situations. It's definitely useful especially for the development systems. And it makes it easier for us to tear things down and not affect teams. If somebody knows, we're going to be regularly doing rebuilds on hypervisors and specific environments, they can leverage either block storage or file storage to make that less impactful to them.
Right. So, yeah, go ahead, Adam.
No,
okay. So I'm still thinking what Brandon said when answering that question from the audience. So some regions, some clusters can have like hundreds of thousands of resources there. So is it the time to start with the RabbitMQ rant here? That time in the show? So what are the big challenge when scaling to those numbers? Because we always discuss Neutron, scalability, RabbitMQ. So what are your findings when running those numbers?
I think very similar. I think everyone's bugbear is probably the RabbitMQ. It's probably the biggest issues that we've seen running at those numbers. Just sometimes the stability with RabbitMQ. So we've actually spent a lot of work recently looking at changing the way we run the RabbitMQ to try and help that.
Yeah, I think the most recent change, well, we've got a couple of recent changes. The last one that was rolled out across the board was switching everything to use individual vhosts per service, which seems to have possibly helped with that, at least allowing us to, if we need to restart a vhost, we can do that and not take every service down.
So you have a big RabbitMQ cluster for the entire region, is my understanding.
Basically, I think the Rabbit is still per cloud as well, essentially.
Right.
So it's not like one per region exactly. There's a number of them per region.
Okay.
Well, because you have difference between the cloud and the region.
Yeah. So this is something that's one of my pet peeves, but there's not a really good way to solve the ambiguity of these terms. So region is a little bit overloaded, right? So there's keystone regions, which we actually don't use. When we say region, what we mean is like geographical region. So a data center is a region.
Okay.
And within the data center region, we have all of these different clouds, which you can think of as basically each keystone instance.
AZ, maybe.
Yeah. AZ is another one that would be very overloaded,
Okay.
right? Because then you're talking about like Nova Neutron AZs, right? Which is different, and we have those, but that's within the geographical region, being DC, and then keystone instance fronting a cloud, and then within that there might be AZs, but the AZs there would all be within the same DC.
Right.
So as soon as you have a keystone, you have a RabbitMQ cluster.
Yes. Yeah.
Okay.
Basically a keystone and a Rabbit, and
Okay.
then a set of other service APIs.
Okay, so it sounds like quite one cluster for multiple OpenStack regions, and it's still a big cluster running for a lot of the computes. And you said you're not separating, for example, Nova and Neutron on Rabbit. I mean, Nova and Neutron are communicating with the same Rabbit.
The same
cluster.
Rabbit instance, yeah. And we've created, like I said, we switched to at least not using all the same vhosts for that within Rabbit.
Yeah.
We've got vhosts per service.
And
Whoa,
you're spawning a cluster of Rabbit, or is it only one server?
Yeah, it's a cluster. So I think we use 3 Rabbit nodes, and then the newest thing that we're trying is quorum queues for Rabbit. So that support just recently got added to Oslo, and we're trying to deploy that presently.
I don't know. I think I'm waiting for Mohammed's reaction about RabbitMQ clusters.
I don't know, man. I appreciate there's I cannot. I'm trying to look up the thread, but I think it's an individual who works at OVH, and he has done an extensive amount of research into like deciphering this issue where if a node of Rabbit goes down, the whole cluster just stops responding to things randomly. He's come up with a reproducer as well, and he has like these two ways that you can run Rabbit, and both of them have drawbacks where it can fail as well. And it's just like I don't know. For us, we're just gonna move away, and we're gonna let Kubernetes. We're just gonna have one node, and then if it fails, Kubernetes will reschedule it onto another node, and we'll have health checks. And I think that's probably the best way to sleep at night, because
we've run into similar issues, right? When one Rabbit node goes down, you think, cool, that's why we have two others, but that's not how it works.
Mm-mm.
So the way that we are doing it at CERN is we don't have RabbitMQ clusters. Mostly, we still have a few. But mostly it's just one node. And if it goes down, it's easier to recover that failed node than recovering a cluster is the way we operate.
Yeah. I think the move is to have one Rabbit like per service. If you can have that, if you have the ability to, like, if you have Kubernetes and you can easily orchestrate them, like one Rabbit per service, and just scale up the resources on it if it needs more, and sleep.
That, I think, that's my personal ideal setup as well, and I've been pushing for that actually. We haven't gotten a lot of traction around that just because the extra resources. Like when you think about that, it makes sense, right? But then when you've got, what did we say, 40 clouds or something, right? Mm-hmm. And then you think about trying to orchestrate getting that many more, where each of these are running on, I think we use bare metal for the Rabbit machines, and there's internally here there would be ACLs and whatever. It's possible, but it's a huge headache, right? To
run them on VMs. We do that.
Yeah, and I used at a previous incarnation of or a previous job, I guess, we did that, and I ran Rabbit per service in Kubernetes, and it was great. But it's a lot harder in this infrastructure. I would love to move there. I really would, or to something completely different. I know I have a friend at Fujitsu who's working on, I think, an alternative to Rabbit for their setup, and or sorry, not Fujitsu, different. Hey, you moved somewhere else, but
would be Line.
We've definitely looked at some other stuff as well.
Yeah,
I think it was Line working.
Yeah. He's at Line.
Yeah, and so maybe to close on the RabbitMQ section of the show, which is a highlight always. We have another question from Seonsu Cho around like beyond those RabbitMQ pain points in scaling. What are your main pain points in OpenStack operation?
Yeah, I think. Oh, sorry.
Go on.
I think some of it is around the automation and deployments and upgrades. I think we've touched on some of that already. That's one of the reasons the UFO upgrade from OKADA project. We're trying to add in containerization. So moving forward with that then gives us the ability to look at possibly using Kubernetes and benefiting from that as well. And then also, I think the other main issue is the regular OS upgrades. How do you do that in a manner that is the least impactful to the business, but also the easiest for the support teams to manage as well? I think they're really the key areas. I know as well James has a desire in the future where I think I mentioned we're consolidating some clusters with the new new clusters we're putting in place. We're going to combine production virtualization with the personal virtualization clusters, retired old clusters. And maybe in the future, have the ability to be able to have, large clusters that supported the whole footprint. So don't have separate bare metal virtualization. Be able to just, the users come in and be able to get any compute resource they desire via flavors. If they need a VM, they pick the VM flavor. If they need bare metal, they pick bare metal. So that's that would be a nice place to be in the future. If we could manage that, I think the team would be very happy.
I guess that leads to another question I have is, would the new cadence that has been proposed by the OpenStack technical committee with like a way to upgrade every year instead of every 6 months, do you think it would help you in with that pain point, or is it still the same pain, just less often, or how does that impact your deployment there?
I'm not sure if that would help us or not, because I mean, given the way that we upgrade, and given that OpenStack has done a pretty good job, I think, of getting fast forward upgrades working, whether we upgrade 1 or 2 letters at a time isn't really, I feel like, super relevant, especially given that in some of our clouds, we're just basically running Gitmaster from some point in time. So when the release actually happens is a little bit less relevant. That said, that doing that does take some sort of vigilance, right? Because you have to know when things are in a sane state. Hopefully people don't merge stuff that just breaks everything mid-cycle with the anticipation that they'll clean it up before a release. But I think it might at least help as a developer, with my developer hat on. I do kind of like the idea of going to those longer cycles, just because the time between like spec freeze, code freeze, all of that is sometimes frustrating for me, right? Because it's like, oh, are we back in code freeze today? Like, seems like just yesterday we were frozen too. I don't know. But with the operator hat on, I'm not sure it really makes a lot of a difference for our model.
Okay, and finally we have one last question from Andrea Franceschini, more of a precision on the previous question we had. Like you mentioned regions with 100,000 nodes. For a single cluster, is that the same? Is it like one cluster for the region, or what's the size you get for a single? You get 2 numbers of nodes for a single cluster.
Some of our single clusters, so the clouds would be, definitely multiple tens of thousands of compute there, whether that's bare metal or hypervisors. Thousands of hypervisors on a single cluster. Much more bare metal. The bare metal footprint we have is rather large in the company still. Something we want to have that shift away from. It goes back to the pets. It's hard to get people to give up their pets.
Yeah, that's definitely on the high side of our usual range at the large scale SIG that we observed so far. And also a question around scheduling in that case, again from Andrea. How does VM scheduling works in that case? Do you schedule across multiple clusters, or do you schedule within a cluster?
The scheduling is all within cluster. So again, everything is very separate, and we do have some AZs, but we also I think there was a question earlier about the ML2, and I still didn't get an exact answer for that, but most of our networking is a little bit more static here. So we use static routing heavily. And so we have a few custom filters for the scheduling that will schedule based on the network that's been chosen and the Nova AZ, and it'll, put it in the right place. I mean, that's not to say that that's really unusual, right? That's basically how it works. But it's pretty much the standard scheduling mechanism, just with a couple of extra little filters in there to make sure things end up in the right place.
Yeah, but if you said you're having custom scheduler driver, it means your scheduler is able to figure out where to place the virtual machine at more easier than an upstream pure scheduler.
I don't think really that much. No, I mean, it's like I said, there's like one or two extra filters, but mostly that's around understanding the static routes. So like if we schedule to a specific network, only maybe a subset of hypervisors have access to that. And so that's just a pretty basic filter, honestly. Otherwise, it's all standard.
Yeah. Is it something you introduced in placement itself, or is it in the scheduler?
So if you recall, a lot of our clouds are running OKADA, which was pre-split placement. So that would be in like Nova scheduler, I guess. But that's easy enough to move into placement. I think we've done that in the case of our newer clouds.
Yeah, but actually we use very similar filter, and actually now it's upstream. It's I don't remember the name.
Routed networks.
Yeah, routed networks. So yeah, we've definitely tried to have some sort of hand in getting that to where we want it to be, light hand, but definitely have been hoping that would get to somewhere where we can just use that, right? Because that would be the ideal. Again, all upstream, no downstream is the goal. If only just because it's way less work for us, right, as operators, right?
So sorry, go ahead, Palmiro.
I was about to change topic, but go ahead if you have something.
I was going to say just about that last note. I think as like everybody, when you start early in your kind of development and operational career, you want to build all these tools and all these like nice creative things. And then the more you do it, the more you're like, I actually want to write the least amount of code possible and maintain the least amount of things. And that's like, as you kind of grow with the career, you're like, that's probably not the path we want to go.
Yeah. So yeah, the topic that I would like to discuss now is bare metal. So you already mentioned that you use bare metal. I know that you are a huge user of Ironic on the bare metal. Can you let us know a little bit more about it? Why you use it? The changes that you needed to have into Ironic to support that scale?
Brendan, if you can talk to the why we use it part, maybe.
Yeah, and you talk to the changes. Yeah, so yeah, I suppose that the bare metal versus VM, it's definitely an interesting topic. Our general, principle is everybody, possible should be using virtual machines, or even better still, a higher level service on top of those virtual machines. Yeah, not necessarily just virtual machines, but in reality, within the business, it's not possible. Not every workload is able to be, used on VMs, or is even appropriate for VMs. And for those situations, we want to have the bare metal available for them. As I said, our eventual plan would be to try and have these combined, so we could support the bare metal and virtualization from the one cloud. But there's definitely a shift. There's a lot of, Yahoo's been around for a long time, supporting large infrastructure. There's a lot of history there, and I think everyone knows, initially everything was built and configured by Yahoo. Trying to sometimes prize that out of people's hands and get them to move to more of a cloud native way is not the easiest. So yeah, we continue pushing. We're trying to lead people in the right direction and move away from bare metal. But I think there'll be always use cases within the company where we have to support that. And we use bare metal. I mean, our clouds are built on bare metal as well. So
yeah. But do you need to have different clouds to offer VMs and bare metal, or you can offer both resources within one cloud?
No, at this point we have different clouds for each. So it would be nice to have one cloud that did both.
So you're saying you're deploying even on bare metal. Are you using OpenStack to deploy your OpenStack?
Yeah.
Okay. And what about the first one? It's the first OpenStack you deployed?
Yeah, the first OpenStack, obviously chicken and egg. We have to have some way to deploy it. But I mean, at the end of the day, you could spin up a standalone OpenStack cluster to deploy the first OpenStack cluster to then use that to build everything else. So.
But actually, we are doing that at CERN. So our bare metal, our compute nodes, they are provisioned by Ironic initially, and then they are hypervisors that host the VMs and then the containers on top that actually host our control plane. And so it's really inception in different ways.
I still think what you guys do at CERN is terrifying, and the idea of trying to bring those VMs back up if the control plane is down, just like, I'm sure you guys have practiced it. Every time I bring it up, it's like, yeah, we've done it. It's not that hard. But just me from like just to grasp it of like my OpenStack runs my control plane is scary for me.
Our bare metal control planes are rebuilt by themselves. If I have to OS upgrade our bare metal, I just use it to upgrade itself. So we take individual nodes out, do OS upgrades, put them back in. Same with a hardware failure. Yeah. So we use the Ironic for all that.
For the bootstrapping.
Initial deployments. Yep.
Yeah.
So and about Ironic, OKADA Ironic, it's quite early version for Ironic.
Yeah, I'll let Adam field these ones.
Yeah, and so I've only recently started looking at our Ironic stuff as part of this upgrade project. I actually was primarily on the VM and Octavia side of things. But I can say, like, yeah, it works, but there was definitely a lot of tweaks to it. I think we had something on the order of 60 downstream patches applied to our OKADA version of our Ironic. Everything from, I think we had a custom quotas implementation to handle the different like network zones and flavors of stuff that people were allowed to use. I think we used a custom. This is where my lack of Ironic knowledge shows. I've got these terms floating around in my head, like Anaconda and IPA, and but I know we used a custom like boot image system, which is now upstreamed, and so as part of that project, we've been able to remove all of those patches, and then a number of patches around speed. So I know there was a few issues upstream where either everything from just listing the Ironic nodes when you have 10,000 of them is rather slow because of the various information that it would fetch in the standard upstream version, to like server deletes. When you delete bare metal, the order that it would do things in, we had to shift a little bit so that it wouldn't take 10 minutes to delete something.
Yeah, there've been a lot of improvements during actually in the performance in the latest versions. Yeah, but I will definitely be interested to hear more when you guys upgrade to a more recent version, because that would be a great talk.
Yeah, I think we've cut the patches more than in half. I think we're down to at least a somewhat manageable number for what we have now, and hopefully in the future we can cut that down even further.
All right, so we have 5 minutes till the end of the show. I think we need to start to wrap up. So how do you see your infrastructure going next? Of course, you want to upgrade, but is there something else in the pipeline, like offering containers and so on?
I mean, so I know we do have a very large Kubernetes team internally that actually, I don't remember whether they're currently running on our bare metal or not. I know they were looking at it for some period of time, but I think containerization is probably not inside the purview of the OpenStack team here. I think we're happy providing like just a large amount of bare metal and VM services to users. The upgrade is definitely the biggest thing on our roadmap right now, and I know we have a few other features we're looking at, mostly around just improving like the speed of things for users.
Right.
I know our newest, I think our newest cloud is the only one that provides nested vert, which was one of the big asks and is going to help get some of the people off of bare metal that previously couldn't. So getting that rolled out more broadly might be one of our things.
Thank you. So I think we have the last set of questions from the audience. Thierry?
Yeah, we have one last question before we close around the services that you have enabled in your deployment. So you mentioned obviously Nova, Neutron. I heard Manila, Ironic. What else?
Yeah, we do use Designate, and we do use Octavia for load balancing. We used to run Ceilometer, but we've since shut that down. Actually, I think. We use Conlan for clustering. I'm trying to think if there's other ones. I think that's it.
So about Octavia, you're using bare metal for Amphora, or
no? We're using VMs for the Amphora.
Okay.
All right, so who wants to go next? Otherwise, we wrap up the show.
If I may ask a few questions about the topic upgrade, not upgrading, but pushing new change on your infrastructure. We already talked a little bit about that, but you said everything is automated. What if you need to roll back a change, or if you have an issue on your infrastructure? How do you manage that? Is there any automated way to I don't know, to heal the infrastructure, or is it a manual intervention you do?
Yeah, it can vary. It depends what the issue is. So we have, as I say, we have automated CI/CD process built on Screwdriver. We also have a lot of like automated testing. So we have monitoring built in. We have a Yahoo internal monitoring, custom monitoring system that we use to detect any problems. And we also have our own jobs that continually build virtual machines or bare metal and just validate that the cluster, everything's functioning. So we get advanced warning if anything goes wrong. And usually when we're doing deployments, because they're bare metal systems, we try and do one node at a time and do a rolling upgrade with validation built into that process. So hopefully we're going to catch things early. Obviously, I think everyone's aware. You're never 100% clean on deployment. So when we do have issues, because we're using Chef and the way things are implemented, rollbacks are not easy. So usually it's a patch and roll forward. And with the CI/CD process, sometimes the testing lead time can be difficult. So we do have ways to do, intervention and patching. Obviously, we can't do a manual. If we're pushing out across the different clusters across the world, we don't have enough people to manually do it. So we leverage, automation, Ansible, or some other automation to be able to help us do that. But it's usually, hands-on troubleshooting, identifying the issue, stabilize as quickly as possible, and then we make a decision. Do we follow up with a new deployment, or do we do a manual push to recover? So I definitely believe moving to containerization is going to help there a lot.
Certainly, and I believe there was something. There's a question about like if there were multiple services that we needed to, or multiple patches that needed to be synced. And yeah, we can pause manually at various stages of the deployment. So we could say right before this is actually going to go out to production, pause and don't roll forward. But also a lot of that's just taken care of automatically, since like Brendan was saying, things will go through multiple. We have like QE, then staging environments that things roll through. And if changes really actually rely on each other, it will deploy one, it will break in staging, test will fail, deploy won't move on, second one will be deployed, it'll start passing, pipeline's unblocked. So for the most part, we don't really have to do that, but it is an option to go in and manually stop at various stages.
And just a quick one, how often do you push new change on your infra?
I mean, it's not really a set cadence. Like we don't have like trains set up or anything. It's pretty much when a commit gets merged, that change gets pushed out. It works its way through the pipeline. So, I mean, in practice, I think we've seen multiple deploys per day or one a week. Or I know we do have like, we run some critical services that obviously around like holidays or special events, we don't want to go down. So we do sometimes do change moratoriums. And in that case, maybe it'll be 2 weeks before a change goes out, but that's generally like the longest I've ever seen.
Okay, thanks.
All right, so let's try to wrap up the show. And I think this question we're gonna do it to all our guests that we have in this large scale show. So with all your experience operating this large cloud, I'm sure you have funny stories, like near misses. Can you share something with us?
Yeah, I'm trying to think about this. I mean,
well, you didn't delete the cloud.
Right. Yeah. I mean, I'm not going to say we've never had any issues. There's definitely been some, but let's just say I've never had anything nearly as bad here as I have at some of my previous orgs. I mean, I could share war stories from previous orgs that are a little funnier, but honestly, I've been really happy with how mature the automation is here, such that most of the time things go out and they just work. I mean, I guess the worst I can think of was, given the scale we operate, a change that appears to be functionally correct and will work in a QE or a staging environment that has 10 or 20 nodes. When it gets pushed out into an environment that has 10,000, might operate a little bit differently. So I think the worst that I've ever seen was when I switched our front end to using USG. Some of the settings that I had for that worked perfectly fine in staging did not appropriately address a cluster of 10,000 nodes in a production environment. And we had our Keystone API basically just stop functioning for a few hours before we were able to resolve that, I think, and that was the case of really all hands on deck, figuring out what was wrong and pushing forward. Fortunately, turned out to just be, for the most part, some settings around like threading, but
yeah,
like
it's when we discover the issue is always something.
I'm a huge proponent of move forward, not back. So fortunately, I've been able to pretty much always make that work here.
I do remember one issue we had. I'm not sure if you were in the team at the time, Adam. It was a while back, and it was very difficult to troubleshoot and identify. And it was happening on the hypervisors. The networking just suddenly went. The hypervisor was active, everything was running, and then all of a sudden we were losing hypervisors across different clusters. And we had everybody. Everybody jumped in, were troubleshooting, taking dumps of the network traffic, looking at firewall rules, looking at everything, trying to understand why these systems are suddenly, we can't even SSH into the hypervisors at all. They're just gone. And we hadn't done any changes recently, and it seemed to be happening quite regularly, but at different times across the cluster. And yeah, we spent.
Well, my guess now is DNS. Like when this happens.
Yeah, that's usually the one, and that was something that we were all like, it could be DNS, but no, this time it actually wasn't DNS. It was actually we found out it was CrowdStrike. The security team had managed to push in additional monitoring and logging within the CrowdStrike software. And it actually brought down the whole network. It got to a certain point and it just blew the network off the hypervisors.
Right.
Yeah, that was an interesting one that took a long time to troubleshoot, shall we say, and there was a lot of people scratching their heads saying, I don't understand this. So, yeah.
So thank you so much, Brandon, Adam. Thank you so much for sharing all of this with us. It was a great show. It was very interesting to understand a little bit more about Yahoo infrastructure.
Yeah, thank you for having us.
Yeah, thanks everyone. It was really a great discussion. I appreciate how much you were able to share during the show. I know there is it's always difficult to talk about internal deployments, but I feel like you were pretty spot on being able to share a lot of details, and I appreciate that. So as a quick reminder, the Open Infrastructure community will meet in person in June in Berlin for the OpenInfra Summit. So I wanted to ask you, is any of you going to be there? I know Mohammed will be, but I don't know about everyone else. Will you be able to join?
Yeah, I'll be there.
I will be there as well.
Well, if you... I would love to be there. I'm still working out whether or not that's going to be possible. I know Yahoo, I think, is still on COVID travel lockdown officially, so we may not have official support to go. But if I can get over there, I really do miss coming to summits and seeing people. It's, I think, one of the biggest great things about this community is getting to all come together like that. So if I can make it, I'll definitely try, but it's not looking super promising at the moment.
Yeah, and I wanted also to mention that as part of the summit, we run a series of open community discussions called the Forum. And if you want to discuss a specific topic with the rest of the community, it is still possible to submit topics until Wednesday next week at cfp.openstack.org. We'll also have an Ops meetup on Friday of the Summit Week in Berlin. It's an event that is dedicated to open discussions between operators, so very similar to what we run today here. You should follow the OS Ops meetup handle on Twitter for upcoming news about this event if you will be in Berlin in June. So that's all I had for today. Let me thank again all of our speakers for today. Adam, Brandon, Arno, Belmiro, and Mohammed for this great discussion, and see you all very soon for another episode of OpenInfra Live.